Hello friends, my name is Bob. In this video I will show you how to find the vector perpendicular to in this case two other direction vector using the TI-84 Plus C Silver Edition graphics calculator. But before I do so, if you guys like the solution, help me press the thumbs up icon below this video. We know that in order to find a vector that's perpendicular to two other vectors, we simply cross the two vectors. And there is a simpler way to do so using the graphics calculator. So the very first step, what we need to do is that we need to consider a vector and b equals to xyz, and then we know that xyz dot 1 negative 1 2, this is equals to 0 because the vectors that we want to find is perpendicular to 1 negative 1 2. And from here, we will be able to construct a Cartesian equation, which is x negative y plus 2z is equals to 0. So that is my equation number 1. We next form another scalar product, this time around xyz dot the second vector, which is 0 negative 1 2. So this is also equals to 0 because same thing, we know that this vector and 0 negative 1 2 is perpendicular to each other. From here we will form another Cartesian equation, so that will be negative y plus 2z, so this is equals to 0, and this will be my equation 2. Once I have these two equations, I can simply move on to my graphics calculator, in which I will find the vectors. All we have to do is to click on apps button, and after clicking the ads button in the screen itself, there are several applications, and we want to use the application number 4, which is the PLYSMLT2 application. We go on to the main menu and we select simultaneous equation solver, which is number 2, and it brings you to this page whereby all you need to do was to specify the equations and the number of unknowns. For this particular case, I have 2 equations, 3 unknowns, and the rest are pretty much as it is. And then we click next. We arrive at this system matrix, which is a 2x4 matrix. So basically the first column is the coefficient of x, the second column is the coefficient of y, and the third column will be the coefficient of z, and last but not least, the last column will just be the values on the right hand side of the equation. And the first row will be the first equation, the second row will be the second equation. So all we have to key in is basically just as follows. For my first column, first row is 1, and then my y has a coefficient of negative 1, and my z has a coefficient of 2, and the values here is 0. Moving on to the second row, the first column is 0 because x has a coefficient of 0, and my coefficient of y is negative 1, and the coefficient of z is 2 and 0. And then after that, once we key in, we can press the solve button, and hence this is the solution. So what is shown down here basically is the equation of the line, and as you know that the equation of the line consists of the position vector of any point on the plane. So this is equals to position vector of a particular point on the plane. In this case is, I think, 0 0 0 plus, and my x subscript 3 on the right hand side of the equation basically is just my lambda. For the x1, it doesn't have anything, so it's 0. x2, it has 2. x3, it has coefficient of 1 on the right hand side. This whole thing itself is basically the equation of the line, in which is perpendicular to the direction vector 1 negative 1 2 and 0 negative 1 2. So all we need to do is to just pluck out this part here. This is actually the direction vector that is perpendicular to the direction vector 1 negative 1 2 and 0 negative 1 2, and this is basically the answer. The vectors that's perpendicular to 1 negative 1 2 and 0 negative 1 2 is basically just 0 to 1. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe for more TI-84 Plus C Silver Edition help. My name is Bob. Thank you guys for support and I will see you in the next video. Goodbye guys.